Hello YouTube. I don't normally speak in front of the camera, but the video you're about to watch is a little bit different to what I normally do, so I thought I'd just take this opportunity to speak to you guys directly. This is the longest video I've created to date, and because it's been edited down from over 4 years of videos, and with a bit of new stuff thrown in there as well, it took quite a bit of effort and quite a long time to get it ready for you. I tried my best to answer all the questions in relation to the build, but if you have any questions that I didn't cover, feel free to leave a comment in the comment section and I'll do my best to answer them for you. If you're a follower of my channel, you'll know that I do lots of different projects, but if you're new to my videos, you might like to subscribe to keep up to date for all the new projects coming out. If you enjoy this video or you find it useful, don't forget to click that like button because that helps me out as well. And now, I hope you enjoyed this presentation of the building of my version of the Terminator T-800 Endoskeleton. I was 14 years old when the original Terminator came out, and I can still remember leaving the cinema and thinking that they had absolutely built that robot. How else could they have got all those shots in that film? While I am a fan of the film, I think I'm really a bigger fan of the effects guys that brought that endoskeleton to life. The concept from James Cameron and the work that was done by Stan Winston and his studio of artists that invented the character, in my mind, is just amazing. And the more and more I delved into the character, the more I understood the phenomenal amount of thought and effort that went into building the endoskeleton in the first place, and the huge amount of detail that went into the character that was never really ever seen on film. A few years ago I was watching the film again with my eldest son. He was probably about 15 or 16 at the time. I can remember him saying that he liked the film, but he thought that the CGI stuff was a bit laggy. So I had to laugh a bit and explain to him that there was no CGI, there wasn't even CGI available when the film was first made, and the laggy elements that he was talking about was done with stop motion. Then of course I had to explain what stop motion was. I think the next film we watched with him was Wallace and Gromit. Looking back on the film 30 plus years later, as far as the effects go in the film, it still stands up to a lot of the very heavily CGI'd films that you tend to see today. While some of the stop motion effects do seem to be a bit clunky by today's standards, I would argue that a lot of the practical elements that you see in the film exceed some of the CGI stuff you see, especially when it comes down to the believability factor. When I first started this project, I had no real idea that it was going to grow into the huge undertaking that it ended up being. And if I knew then what I know now, I'd probably have never taken on the project in the first place. Like many things in life, it started out as a fairly small idea, and I originally had it in mind that I was just going to build the arm from the Terminator 2 movie. And after doing a bit of research, I found that there was a DIY kit available, and while there were a few licensed versions available, by the time I got around to the idea of wanting one for myself, they were extremely hard to come by, so the do-it-yourself kit ended up suiting me really well for what I had in mind. When the kit arrived, it had already had one piece in the collection of parts that was broken, and whilst it sort of glued back together really well, it became clear pretty quickly that it was definitely going to be the type of piece that would end up being quite delicate, and certainly would obviously only be for display. Where possible, I did replace some of the smaller elements and things like the cables and that sort of thing with real metal. It took me quite a bit of time to get it to the point where I was happy with it, and when it was finished it sat on display for all of about 3 days before it ended up getting knocked off and shattered to pieces. As you might imagine, that was quite disheartening, and as a result I didn't really have the heart to rebuild it given how badly broken it was. So partially to console myself about the idea, and as a bit of a consolation, I decided that I'd try and work on one of the endoskeleton heads that I'd found was also available as kits when I was doing the initial research for the arm. The head kits were made from a vinyl type plastic rather than the resin that the arm was made from, and were certainly a lot more durable and bump proof than the resin stuff that I'd already worked with. When the model arrived, I quickly realised that there was a lot of dead space available inside the head that I can do stuff with, and while the detail on the head itself was pretty good, things like the neck and that sort of stuff lacked any real way of being able to pose it into different positions, and I kind of liked the idea of being able to change the way it looked. So I came up with a way of doing an articulated neck system by building the neck pieces into individual sections so that the head could be moved around a little bit and posed into different positions. The other thing that I was able to do was to do a cutaway section, and that cutaway section revealed a small screen that was hacked down and rewired from an old Nokia mobile phone. And the little screen that you could see in that ran a video on a little mission report setup, and it ran on a continuous loop. And the CPU chip that I made to go inside the head was pieced together from real parts from an old computer motherboard, which gave it a really nice realistic sort of look to it as well. The broken arm pieces sat in storage whilst I was working on the head project, and after being happy with the way the head came out, I decided it was time to sort of dust off those broken pieces and see if I could do something with them. Years before, I'd done a course on casting aluminium, and I thought there was a pretty good chance I'd be able to make up the elements in aluminium and come up with something that was a little bit more substantial and certainly a lot more sturdy than the resin version. While doing more online research for the details on the arm and hand and that sort of thing, I actually came across a forum, which was the Endo Builders Club, which ended up being a great wealth of information, and there was a great bunch of guys that gave me heaps of encouragement as the project went on and became increasingly more complicated. There were quite a few differences in design in the arm between the first and second films, most notably in the fingers themselves, and with the first film costing $6.4 million, as opposed to the $100 million budgeted for Terminator 2, it's not surprising that they were able to do some upgrades. And the overall design for the endoskeleton stayed pretty much the same, but the extra finessing of the finer details meant that they could get a better performance out of the character. One of the reasons why I started on the arm first was because of the level of sculpture detail that was in it, and if I wasn't able to produce the cast aluminium, there really wasn't very much point in trying to do the rest of the skeleton. I had the pieces, the broken resin hand and arm to work with, but that was still essentially just the forearm section and only went up to where the elbow connected to the upper arm. After doing a bit more research, I found that there was a papercraft model version available of the endoskeleton. The problem with it though is that it was only at half scale, and after checking out measurements, the original model had to be increased by 110% rather than just outright doubling it. This gave me a pretty good indication for the layout of the individual parts though. What I had in mind was I was going to make up the skeleton pieces out of wood and use those wooden pieces as pattern pieces for the casting of the aluminium. And I did actually go so far as to make the upper arm piece, as well as being able to make up the pistons for the bicep and tricep parts of the upper arm. Once I had all the pieces cast, it was a matter of getting them cleaned up and ready for polishing. Slowly but surely, as the parts came together, I was able to see that I had a viable option for making a complete metal version. There was over 100 parts that made up the hand and fingers alone, but seeing it all put together and finished really spurred me on for the next part of the project. Shortly after the completion of the arm, I started thinking about the possibility of working on the head, and once again after a fair bit of research, I found that the head that I'd made previously didn't have the right scale to it in relation to the arm and the skeleton itself, and whilst it was marketed as a 1:1 scale piece, based on the original movie version, it was more like a 3/4 scale size. This meant that while the details were pretty good on the skull itself, I'd have to work out a way of enlarging the head so that it didn't look tiny when it was attached to the rest of the body. It was around about this time that I ran into a guy on the forum who had a complete resin kit of the Terminator that he'd managed to buy himself some time ago, but hadn't had a chance to do anything with because essentially he just didn't have the time, and it was basically just sitting in a box in storage. He also mentioned that the condition of it left a lot to be desired, and that it would be a lot of work to get it to a finished piece anyway. As it turns out, he was also living in Australia, and these sort of kits over here are exceptionally rare. And whilst he was in Melbourne and I was in Newcastle, we were able to strike up a deal where he would send me his incomplete kit and I would finish it for him to the point where it was ready to be assembled. And in doing so, I would be able to take those parts and use them as pattern pieces for creating my metal version. And so the deal was struck, and when the amalgamation of those parts arrived, that's when the project really started to take off. This now meant that I had a head that was the right size, and now I could start tackling what was probably the most complicated part of the build. I used the original head as a frame of reference, and then I cut up one of the tie kit versions and reassembled it into the correct scale to give me the pattern pieces I need to do the individual pieces I needed for casting. The technique I was using for melting down and casting the aluminium is called green sand casting. Green doesn't relate to the colour, it's just a way of describing the moisture content of the sand. The method of casting that I was using also meant that I couldn't produce hollow parts. When you're doing resin casting, you can do what's called roto casting, which allows you to slosh around the liquid resin inside the mould as it starts to harden, leaving you with a shell type sort of construction. Given that I was working in molten metal though, this was certainly not an option, which means a lot of the larger parts had to be deconstructed into their component elements and then reconstructed as a kind of three-dimensional jigsaw puzzle. It ended up needing to be broken up into 8 individual pattern pieces so that I could get it cast in the aluminium. This is where those lines and seams and joins that were laid down by the original sculptors ended up being really helpful, because it meant that those artificial seams and joins would transfer into a real-world option for reassembling the component pieces back together. When the kit arrived, one of the first things I did was to take photos of all the parts and catalogue and measure all the dimensions as best I could. As I said, these kits are extremely hard to come by in Australia, and photographing them in this way was the only real backup I had for replacing parts should any of the restoration process go sideways. Thankfully, most of the kit was relatively complete. It was missing a section of vertebrae between the top of the spine and the bottom of the neck, and that was a section I had to custom make to bring the spinal column all together. As I tackled each individual piece, they all had to be cleaned up and prepped to a finished level. A perfect example of this is the pelvis section. It had a lot of symmetrical areas that needed fixing, and while every part was not as complicated as this one, every part had to go through some variation of this process.
Once the entire collection of parts had been corrected, resculpted and then reassembled, the entire process used over 6 kilos of body filler.
Then they had to be broken apart into individual pattern pieces that would be suitable for casting, and then finally reassembled as part of the cleanup of the resin kit. Later on I would use these as remastered pieces. Once I had these remastered parts, I then used them to make silicone moulds so that I could duplicate the resin pieces into new fresh components that didn't have any of the problems associated with the original pieces. As I started to make this thing, this fantasy piece from a film, I started to realise that every line, every seam, every join, every anatomical piece that went into building the way the skeleton went together, there was thought behind how the parts went together. From the assembly and the joinery of the skull, to the way the hand and fingers and piston pieces would move and articulate in relation to each other. They weren't just painted on elements, they weren't just things that did nothing. Each part was there for a reason, and you could see the thought of the original sculptor. It simply wasn't good enough for a piece to go together and be on film for 5 or 10 seconds. If it looked like there needed to be a seam or a join in a particular location, it was included in the way they sculpted it. And as a result, as I started building the character myself, because I was now working in metal, whilst the original sculptor was working in ways that meant that the part themselves may have had to be made in a static, unmoving form, I was going to be able to work with the groundwork that they had laid down, take what I saw as being the best elements from both films, from the miniatures through to life-size pieces and all the individual pieces needed for the independent shots, and incorporate them into one complete, fully articulated model. One of the goals I'd set myself was I wanted to make it, for want of a better term, as real as I possibly could. All of the collectible versions that I'd seen available were all static displays or had a very limited degree of movement in relation to the head and arms, but for the most part were just set in a fixed pose position. And even the versions used in the film didn't really consist of a complete, fully articulated version. Rather, they were a collection of parts and statue-type pieces that were used for individual shots. There were a number of full-size versions built, but even they had very limited mobility. I wasn't looking at making an animatronic version. Rather, I was after something that was more like the ultimate action figure. Something that could be posed in any position I wanted, so that it could be adjusted and adapted into any pose that I like. Because I was working to achieve a version where all the joints moved and operated appropriately, quite a few joint areas were sculpted into a fixed position, and those pieces had to be resculpted so that a working joint could be put in its place. As a result, I had to make up quite a few custom tools that were specifically designed to shape or cut out sections for the ball joints in the legs, as well as the spine and neck areas. This was pretty easy when it came to the resin, but when I started working with the metal, it was a completely different story. Some of the larger areas, like where the piston rod ends connected, had to be cut out and recarved from essentially what was a solid chunk of aluminium. So once again, I had to get creative with how I was going to do that. I initially burnt out the motor and probably 2 Dremel machines, trying to carve away at the metal, before I ended up creating a super-powered engraver that was made from a stripped-down wood router, and then it was hung from the ceiling of the workshop and negatively balanced with springs so that I had a bit more of a chance fighting with the power of the torque of the machine. It was a bit of a hairy experience using it, but I managed to keep all my fingers during the process, and it certainly tore away at the metal and carved it up like I needed it to. At this stage, it's been 1 year and 3 months since I first fired up the furnace and started melting down metal, and whilst it hasn't all been easy, I've learned a lot as far as the casting of the metal is concerned. But one of the things I've had to struggle with was the casting method that I was using itself. Whilst sand casting is a pretty quick method of casting metal, it does have certain limitations in terms of what you can achieve with it. You can get a reasonable degree of detail from it, but a high degree of detail and things like undercuts from overhanging areas are very difficult to achieve in that sort of method of casting. There was a lot of parts that ended up taking a hell of a lot of head scratching when it came to breaking them down to individual elements that could then produce a mould that a solid piece could be then cast from. The elbow joint was a classic example of something that, at first glance, looked like it'd be incredibly simple to do, but because of the angles and undercuts that were associated with creating it, ended up being really quite a difficult part to create. As a result, I had to do quite a bit of compromise when it came to the really fine details, meaning a lot of those fine line details had to be recut in by hand as the pieces were cleaned up and then reassembled. Most of the engraving and recutting of lines were initially done with a regular rotary engraving tool, but then I ended up getting a renovator tool, a vibrating cutting machine, and I found the ability to create straight line engraving with that, and even the depth of cut was a lot easier than the rotary tool, and gave a much more reliable and straight line. I still used the rotary tool to go back and touch up corners and other particular areas where the vibrating tool wouldn't get into. I even went so far as to cut down and modify some different cutting heads for the machine, which again assisted me in getting down to some of those finer detail areas, and even assisted me in doing some curved lines, which can be quite tricky as well. As I said, all the individual parts had to be broken down into their component elements. The biggest problem with that in comparison to the resin stuff is that when it came to putting them back together, there was no easy way of doing it in terms of stretching the material or adding in filler or glues to get the metal to align properly. And because of that, a lot more time had to be taken in terms of lining up the metal, as well as working out structural ways that the joints could be put together. A lot of the time it just meant working a lot more slowly and filing and grinding away at the pieces until they were able to jigsaw puzzle together appropriately so that all the seams and joints could be hidden within the construction of the piece. As I was working, I took time out to polish test areas, mostly to make sure that there wasn't any tiny little bubbles left behind from the casting process. But I must admit, polishing up these little pieces as I went did certainly spur me on in terms of having greater hope for what the project would look like when it was finished. The joinery as far as the chest and back pieces was quite complicated, and a lot of the time I was able to use the original lines that were sculpted into the piece to create the real world joins. Quite often there was no real indication of how those joins themselves should go together. As a result, I had to come up with a lot of ways of hiding those areas. Thankfully though, the casting method I was using provided me with thick enough pieces of metal that I could work out ways of doing hidden joins that were only visible on the inside parts of the back plate and chest plate, and left the visible surfaces on the outside pristine. When I started working on the spine, I had to customise all the vertebrae pieces so that I could get it to fit together the way I wanted it to, and the central section of the spine that I made, which was the piece that sat inside the chest cavity, was the only static part within the entire length of the spine. It was produced with a hollow section in the centre to allow for two mounting points, one that ran up to where the head attached and the second ran down to where the pelvis attached. There's a stainless steel cable that runs through each of the vertebrae and connects to this central mounting section of the spine. The tensioning of that cable allowed for the spine to be either fixed and rigid or by loosening off the tension and making the spine flexible. While the biggest pieces I cast by size were the upper leg pieces, the thigh pieces, the largest piece I cast by volume of metal was the back plate itself. It was still cast in two pieces, as opposed to the four pieces that it took to cast the chest plate, but because the back plate was going to be the central support section for the spine and was also the primary mounting point for where the arms connected, I needed to make sure that it was a particularly strong component. So the metal in the back plate was cast to be about 50% thicker than the metal in the chest plate to allow for this extra strength. The feet and toes is another example of a piece that had to be extensively resculptured based on the original parts that came within the kit. The foot had simply been cast in such a way that all the pieces would have been glued together into one piece. Then a piece of pipe or tube would have been passed up through the centre of the foot into the lower leg, into the calf section of the leg, and that's probably how they would have attached the feet to whatever base they wanted it standing on. Because I wanted to regain the movement in the toes, I essentially just cut up the resin pieces into their component parts and then cleaned them up for casting pretty much the same way as I did for the fingers. The biggest difference between the fingers and the toes is the toes were significantly less complicated, and when it came to the rejoining of the toes they only required hinge pins as opposed to more complicated screws and pulleys that were used in the fingers. But once I had an aluminium casting of the foot, I wanted to make sure that the toes would align and operate properly as well, so I made a small mock-up piece in wood, once again in a similar way that I did with the finger, just to make sure that they would move and articulate properly. Once I'd done that, I cleaned up and polished one of the pieces that I'd previously cast and drilled out the section for where the plunger for the pistons would go, just to make sure that it would actually operate the way I thought it would. Now that I had all the component pieces for the foot, it was a matter of cleaning them up and getting the pistons to operate the way they should. And whilst a big part of this sort of project is doing your research, unfortunately there was very little available on the foot itself. I found some original pictures that was taken from some of the screen used versions, but things like the underside of the foot and a lot of the small details in relation to things like cables and pistons were extremely hard to work out. As a result, I sort of reinvented the wheel a little bit and came up with a system that I thought was appropriate to the way that it should operate and should look. And I even went so far as to add in component pieces that probably didn't exist in the original version. And while probably nobody but me will ever know that they're there, they're just little details that I think that should have been included. And my crazy pursuit of trying to put in details just wouldn't allow me to not include them. At this point it's been 2.5 years since the project started, and all the necessary pieces I need to finish the endoskeleton have finally been cast. 211 independent pieces altogether. Now comes the real work of cleaning up and polishing all the components and making up all the little accessory elements that need to go with them, as well as all the cabling and hydraulic hoses that would need to connect to the pistons.
The cleanup and polishing process basically consisted of 10 steps. The first thing I had to do was take the raw casting and cut off any of the areas of flashing, as well as the sprues and risers that allowed the molten metal to be poured in the first place. From there, either with a combination of a hand file and a regular angle grinder, I would cut those areas back so they would match the other surfaces of the metal. Then I would switch over to an 80 grit flappy disc again on the angle grinder, and as best I could go over the entire surface to even out the texture. And unfortunately, any of the areas that the flappy disc wouldn't reach, I simply had to polish by hand. And that was mostly done with very small tooth files and needle files and varying degrees of grades of sandpaper, ranging from about 40 grit up to about 800. This process had to be repeated on every piece until the metal surface had reached at least a minimum of the 120 grit. Any less than this and the polishing process couldn't remove those lines, so a lot of the time there was many small areas that needed further sanding to ensure a proper polish. Once it was done to that minimum standard for sanding, I would go back and cut in any of the missing line detail that was missing from the piece, and repeat that sanding process one more time before it was ready for polishing. From there, the buffing process consisted of a cutting stage, and then finally a polishing stage to finish off the surface of the metal. Finally, when all the parts were polished to a chrome shine, the entire surface of the piece was washed down with mineral turpentine to remove any of the polish residue that had been left behind. Varying degrees of difficulty from piece to piece means that this process had to be repeated up to 3 or 4 times per piece. As each section of the endoskeleton was completed, there was a lot of test assembly that was required to make sure that all the parts went together properly. This was done at varying stages of the polishing process to make sure that the parts went together properly before the final cleanup. And this also allowed me to see where the most exposed areas were, so that I could pay more attention to polishing and cleaning up those areas. A lot of the pre-assembly was done on a section by section basis. A good example of that is when the legs started to connect to the pelvis section, because there was a number of adjustments that needed to be done to get them to operate correctly, including adjusting the angle of the ball joints that came off the hip pieces to allow for the greatest range of movement for the legs. Doing it this way and working on each section independently meant that I was able to get the most amount of movement out of each of the associated joints that I was working with, and this sort of allowed me to debug any problems that would come up with any particular piece connecting to its corresponding component. The true range of motion in the endoskeleton doesn't really match what's capable within normal human movement, but given the limitations of the metal, I think I was able to get the widest range of movement possible on each piece and still remain true to the original design of the skeleton. The piston pieces that go throughout the body were all pretty much made as a solid cast piece, and then drilled out to accommodate the plunger rod, the control rod. The holes that I drilled in were significantly deeper than required to allow for the rods themselves to go in. This extra depth allowed for the movement of the rod and thereby the movement of the joints themselves. And that also allowed for the control rods themselves to be longer than required, so that when the joint was fully extended, the rod wouldn't fall out of the hole. I used a hollow aluminium tubing for the rod, and the inside diameter was an appropriate size so that a rod end could be thread tapped directly into the end of the rod. The rod ends were a ball type connector, which allowed for a little bit of sideways play in the movement, and one of the few parts I didn't have to create from scratch. All of the pistons were pretty much done in this same way, except for the 2 pistons that connected from the hip to the torso section. Those 2 pieces had a double control rod, one that had telescopic movement with inside the other, and pushed up into the body of the main piston. That allowed me to get a double action within the piston, and created a more robust looking piece rather than just a very thin control rod. Once I had a working collection of parts like an arm or a leg, I was then able to start connecting it to the main sections of the body, and start working out where the connection of the pistons and control rods needed to be attached to. A lot of the time this was a trial and error process, because it wasn't unusual to find that something would obstruct the movement in some way, and that would require a custom adjustment or even a custom made part that needed to be added into the construction. Usually this was just as simple as putting in a spacer piece, or modifying the mounting ends for the pistons so that they would connect properly to the skeleton without restricting movement. When it came to the small pistons for inside the chest cavity and to the neck, there are a number of different versions that show these being connected in slightly different ways. The style that I went for was based on both the first and second films. Some of the details were also taken from a 1/4 scale model of the endoskeleton. The reason why I use that one in particular is because, like mine, the spine section continued all the way through the body, as opposed to a lot of the models where the torso was a sealed off area. This gave me a greater indication of where the mounting point should connect to the interior areas of the torso, chest plate and back plate, as well as a couple of mounting points that connected directly to the spinal section as well. Like with the arms and legs, I worked out the shoulder motor and shoulder blade section first, and once I had all the parts mounted and working the way I thought they should, I then just mirrored that same technique to the other side of the body. Another interesting element of the shoulder motor section is the gearbox piece that attaches the shoulder blade to the motor. The technique that the original sculptors used for this is commonly called kit bashing. The idea is that you take details from other model kits. This allows you to put in details quite quickly without going through the need to sculpt every single element of it. The gearbox inside the shoulder motor was actually taken out of a Tamiya Sandscorcher RC car. This same gearbox piece was also used in the side of the head, and then it was further finessed in details that were taken from a model of a German 88mm flak gun. One of the things I did a little bit differently to the original design of the endoskeleton was how I connected the pistons that ran from the top of the shoulder section to the backplate section behind the neck, as well as the neck pistons themselves. In the first film there was a little bit of a continuity error in the way they filmed one of the shots, because in one shot the hoses and pistons are connected to the head, but in the next shot the hoses and pistons have been removed. The reason why they did this is because to get the shot they were after, the head had to be tilted back to look around the room, and to be able to get that effect they had to remove the piston pieces that would have restricted the movement of the head. So the adjustment that I made was to mount the pistons for the head to the lowest part of the vertebrae of the neck, and that gave me a much wider range of movement in the head, from left and right, as well as being able to look up and down. Another tricky little piece that needed making was the jaw pistons. It's not that it was particularly more difficult to make than any other piece, it was more a matter of that the size of materials, the gauge of metal that I was using was very hard to come by, but as luck would have it I was able to find some small aluminium wind chimes that had the right gauge of metal that I was looking for, and the two sizes that they were available in just ended up being the right size that I needed. One version was hollow and the other version was solid, and the solid version slid very nicely into the hollow piece, which allowed me to get the mechanism I needed for these miniature pistons. One of the refinements they made between the first and second film was in the teeth. In the first film the teeth were just shown as being metal, the same as the rest of the endoskeleton, but in the second film they were shown as being more like real teeth. That more realistic look was the style that I decided to go with myself, and I was able to order a set of acrylic denture teeth off eBay, and that served the purpose really nicely. Whilst all the cables and hoses that connected throughout the body weren't real working parts, as much as possible I did make them from real world equivalent components. The hoses were made from a stainless steel braided hydraulic hose, and the connecting elements were made out of small pieces of aluminium tube that were custom shaped to fit the end of the hose. The cable elements were hand wound using an electric drill, and was made from 0.9mm stainless steel MIG wire, and wound around a 2.4mm stainless steel rod to achieve the thickness that I was going for. These two different types of setups, the hoses and the cables, were then put in place to match what I thought would be the most appropriate position for them. The cable type pieces would be mounted to lineal actuator pieces, whilst the hydraulic hoses were mounted to the larger pistons of the arms and legs. In the pursuit of details though, when it came to the hoses and cables, there was literally no information that I could find that related to where those hoses and cables actually connected to. As a result, I made up a purely custom made piece that I thought would suit in with the style of the character, and to me it made sense that a part like this would actually have to exist. I set it up so that it mounted in front of the spine behind the chest plate, and acted as a distribution hub for all the cables and hoses that ran into it. And I think it ended up just being a nice little detail that tied everything together, rather than just having the cables floating around loosely within the chest cavity. The bulk of casting done in the project was largely done from cast aluminium. The only real exception to that was a small piece of detail that was lost during the casting process on the chest section, as well as the two gearbox type pieces on the side of the head. These pieces were cast from pewter to get the additional detail that I needed from them, but once they were polished, they matched in quite well with the rest of the metal, and it was just a much more practical way of regaining those lost details. There's very little in the way of electronics that go into the model itself. The only real setup that required any sort of electricity was obviously for the eyes. I went through a number of different versions for the filters and lenses for the eyes before I was happy with what I came up with. In the end it was made up of a stack of different elements. The first part was a piece of red opaque perspex, and on top of that there was a piece of cut glass that was in a very deep red colour, and sandwiched between these two pieces was a very fine mesh fabric that diffused the light into a grid pattern. And then it was topped off with a shaped lens which was cut and polished from a clear piece of perspex. Behind these elements was just a white LED with a directional lens, and then the wiring passed into the head, where it was married up with a small resistor that allowed both eyes to be run off a 12-volt power supply. The wires then ran through one of the hydraulic cables that attached to the side of the head, and was hidden within the massive cables inside the torso. I could have just done a battery that was hidden inside the skull, but I didn't want to have to pull the head apart every time I needed to change a battery. Between the cleanup of all the parts and working out where all the hoses and cables should run, the skeleton was probably assembled and disassembled probably a total of about 4 times. This was basically just because of all the little nuances of getting everything to fit the way it should and operate properly in relation to each other. Once I started getting into this level of detail, the amount of reference material I had on the subject started to run out in terms of knowing exactly where things should be placed. As a result, I had to do a lot of best guess placement as far as the hoses and cables were concerned, but a lot of the time the design of the piece told me exactly where the pieces needed to be for it to operate correctly. I was now at a point where I could start thinking about what he would be standing on. The biggest problem now was the overall weight of the character, and I needed to have something really substantial to hold it all up in place. I started out with a piece that was about 1 metre square of 5mm steel checker plate, and to that I welded a triangular style pyramid support frame, with the centre section of the frame being made up of 2 sections of tubular steel, one that would telescope inside the other. This central tube was connected to a screw thread that was driven by a motor that was taken from an old treadmill, and that gave me the ability to adjust the height of the figure as I saw fit. The top of the support piece then had one final piece of tube added to it, which was capped off and welded so that it could act as a quick release for lifting the body on and off the mechanism. An extra piece was then welded to that cap piece with a mounting plate that connected to the base of the pelvis and was bolted in place. This gave me enough structural strength to support the entire weight of the endoskeleton, and gave me enough travel in the screw thread to set it in a low enough position to make it look like the skeleton was kneeling, or have it set in a fully upright position when the thread was fully extended. Because it was a screw thread system, it was also very easy to actually have it set in any position in between. Once the lift mechanism was all worked out and operating correctly, the more decorative elements of the base were able to be added to the top of this support structure, and acted as a very effective method for hiding all the elements that actually hold the endoskeleton in an upright position. I had a pretty clear idea in mind on what I was going to be using as far as the base for the display stand. The look and style of it was relatively straightforward, and pretty much just matched the theme that was already laid out by both films. The biggest point of difference that I wanted with it is that I wanted to create the illusion that the Terminator was standing in amongst fire, so as a part of the display base, I created a pretty realistic looking artificial fire effect that I think ends up being a fairly nice feature for the final display. And with that, I was able to start with the final assembly of bringing all the parts together and finally completing this monumental project. Consisting of over 280 bolts, lock pins and screws, 60 hoses and cables, with over 570 custom made parts, and more than 230 points of movement. The total figure weighs 135 kilos. And after 4 years, 1 month and 24 days, one day before my 45th birthday, the project was finally complete.